Okay, 5-5, linear inequality in two variables. A linear inequality in two variables is a relation whose boundary is a straight line, and it resembles a linear equation, but the inequality symbol is there instead of an equals. So you're going to have a less than, greater than, less than or equal, greater than or equal instead of an equal sign. The graph of the inequality is a set of all points whose coordinates satisfy the inequality, so all the true points. And this is a vocabulary word, half plane. Um, and that just means that the graph will be separated in two separate regions. Those are called half planes, even though they might not be exactly half. Okay? So let's move on. Here's your how-to slide. Graphing a linear inequality in two variables. The first thing you should do is determine whether you want a dashed line or a solid line, and then graph the line as if it were just a linear equality. So pretend it's an equal sign, graph the line. To determine whether you want a solid or dotted line, dashed, it's going to be just like when we do a number line and we have open and closed circles. So if we have the equal sign, meaning that the points are included, then we want a solid line. So extra ink here means we have the full line. If you don't have the equal sign, that means that point is not included. So on a number line, it would be a open circle if we were doing it in one variable. But if you have no equal sign, so just less than or greater than, then you got a dashed line. Once you have that line drawn, then you want to choose a test point from one of the half planes. Make this easy. The easiest point you can pick is 0, 0, because everything times 0 is 0. So if it's not on the line, use 0, 0. If 0, 0 is on the line, you cannot use that. Then you're going to have to pick a different point. So pick something easy, something like 1, 1, 10, 10, 5, 10, 2, 1, something easy. If you get a true statement when you put that point in for the x and y, then you want to shade where that point is. If it's false, that means that entire half plane is false, and you want to shade the other side of the line. Let's do some examples. So, graph 2x plus 3y is greater than 6. So the inequality symbol is greater than. Our boundary is going to be dashed. Okay, now we could plot this with the intercepts, but we're going to go with the tried and true slope intercept form. So we're going to subtract 2x from both sides. Basically, we're getting the y by itself. And we get 3y is greater than negative 2x plus 6. Then we divide everything by 3. And we get y is greater than negative 2/3 x plus 2. So here's where we start on the y line when we're graphing. So there we go. Then our slope is negative 2 over 3, which means we go down 2 and over 3. And we just keep going. Okay? Then we connect all our little dots with a nice dashed line. All right, now it's time to test the point. So we're going to test the point 0, 0 because it's not on our line. So we're going to substitute 0 in for x and 0 in for y. So we get 2 times 0 plus 3 times 0 is greater than 6. I don't know. Is it? Well, is 0 greater than 6? No, that's false. So this is false. That means everything over here is false. So we want to shade the other side. Okay? So now let's graph y is less than or equal to negative 3. The boundary is the graph of y is less than or equal to negative 3. So because it's less than or equal, the boundary will be solid. Okay, how do we graph this line? Is it horizontal? Is it vertical? What? Okay, don't panic. We're going to pick 2 points where y is equal to -3. Remember, y is the second part of your ordered pair. It's the second coordinate. So let's pick 0, -3, and -3, -3. Okay? So then we're going to plot. So x is 0, y is -3. X is 0, y is -3. And then -3, -3, it's right there. Then we can connect the 2 points, and we have a horizontal line. So we have our line drawn. Step 1 is done. All right. Now we have to find our test point, 0, 0. But how do we test it? There's no x to put the 0 in for. It's okay. There's no x. We don't have to worry about it. We're just going to put in our y. So 0 is greater than or equal to -3. Yes, 0 is greater than or equal to -3. And we shade where the point is. Okay. Oh, here we go. X is greater than 2. So what's our boundary going to look like? Is it dashed or solid? No extra ink. It's going to be dashed. So just like our last example, what we're going to do is we're going to give ourselves 2 points here where x is 2. So the first coordinate is 2. So we got 2, 0 and 2, 2. Well, when x is 2 and y is 0, there's your point. And when x is 2 and y is 2, there's your point. And we connect those with a dashed line. Oh, look, we have a vertical line. And just like the last example, we have our test point, 0, 0. But we're looking at these, we don't have a y to put in. So we just don't pay any attention to the y. Just put in the x coordinate. Is 0 greater than 2? No. No, it's not. So we aren't going to shade the side where 0, 0 is on. We're going to shade the other side. So just as 2 or more linear equations make up a system of linear equations, 2 or more linear inequalities make up a system of linear inequalities. So we have two inequalities with the same variables. A solution of a system of linear inequalities in 2 variables is an ordered pair that satisfies each inequality in the system. So the solution set is the set of all ordered pairs that satisfy each inequality in the system. So to graph a system of inequalities in 2 variables, begin by graphing each individual inequality in the same rectangular coordinate system, and then find the region, if there is one, that is common to every graph in the system. We want where it overlaps. The region of this intersection gives a picture of the system's solution set. So let's do a little example, okay? So just like before, except there's 2 of them. So we have x minus y is less than 1. 2x plus 3y is greater than or equal to 12. So let's start with this one. We need to get it in slope-intercept form, so we're going to get the y all by itself. So we subtract the x. Then we have a negative y. It is not all by itself, so we have to divide everything by -1. Remember, when we divide by a negative, we have to flip the sign. So we get y is greater than x minus 1. We're going to start here on the y line at that -1. And then our slope here is 1, which is up 1 over 1 to the right. We just plot all those little points. And now, are we using a dashed line or a solid line? we're using a dashed line. Whoop. There you go. We have that one graphed. The line of it is graphed. So now let's look at 2x plus 3y is greater than or equal to 12. We're going to subtract 2x from both sides. We're doing the same thing. We're getting that y by itself. Then we're going to divide everything by 3. And we get y is greater than or equal to negative 2/3 x plus 4. So we start at the 4. And then we go down 2 over 3. And that's there. And then there. And there. And this time our inequality is greater than or equal to. So it's got the extra line. So our line is solid. Terrific. Now we still have to test some points here. So let's use our trusty 0, 0 point because it's not on either line. And let's start with the x minus y is less than 1. Plug this into your original equation. So is 0 minus 0 less than 1? Yes. 0 minus 0 is just 0. And 0 is less than 1. So we're going to shade this side of the dashed line. I didn't shade it all in because this is going to get a little messy for a second. So this side, where 0, 0 is going to get shaded. Then we're going to do the same thing. We're going to test our 0, 0 point. We have 2 times 0 plus 3 times 0. Is that greater than or equal to 12? Is 0 greater than or equal to 12? No. So we're going to shade not the side that includes 0. We're looking at this line right here. We don't want to include the part that has 0, so we're going to be shading up here. Now, the solution is going to be where the overlap is. We have 4 separate regions. 1, 2, 3, 4. This section up here, we have the blue and the red lines. So this section right here is where we shade. Okay? That's it for today. Have a great day and be safe.